When we think about the most terrifying things in the universe, what's the very first thing that pops into your head? For most of us, it's probably the black hole. A black hole is like a monstrous cosmic vacuum cleaner, relentlessly sucking in massive amounts of matter the moment they cross into its gravitational grasp. Its pull is so unbelievably intense that even light itself doesn't stand a chance of escaping. Not a single photon can break free, not even the tiniest glimmer, and that's exactly why we call it black. Utter, complete darkness. Is it even possible for anything in existence to be darker than that? Hey there, everyone! As wild as it sounds, the answer is yes. And that pitch-black horror might just be something known as the quantum singularity. Welcome to our channel. We're really glad you're here. Because today, that's exactly what we're diving into. The fear of the unknown. What is it that human beings fear more than anything else? After all, every danger we can see or imagine, no matter how terrifying, always has some kind of boundary. In other words, it can be measured, or at the very least estimated. And that, strangely enough, gives us a certain sense of comfort. But what if, in principle, something simply can't be measured or predicted? Uncertainty, that is the root of our deepest, most primal fear. And there may be nothing in the universe more uncertain, more unknowable than the quantum singularity. It is the purest form of uncertainty imaginable, in the most all-encompassing sense of the word. A quantum singularity is a purely theoretical point where two completely incompatible pillars of modern physics violently collide: Einstein's general theory of relativity, which governs gravity and the large-scale structure of the cosmos, and quantum mechanics, which rules over the strange and tiny world of the subatomic. Inside a singularity like this, space and time themselves lose all the meaning we're familiar with. The laws of nature, the ones that work flawlessly from here on Earth to the edge of distant galaxies, completely fall apart. It's as if reality itself has snapped and shattered. Or maybe it's the beginning of an entirely different kind of reality. The beginning of everything. The sheer potential power behind this uncertainty, the mind-bending, truly limitless possibilities it holds, can be glimpsed through one incredible fact. According to the most widely trusted and scientifically grounded theory of how the universe began, our entire cosmos was actually born from a quantum singularity. Every last star in the night sky, every inch of space stretching across billions of light years, all of it is the offspring of a quantum singularity. And here's the part that's both terrifying and fascinating at the same time. This quantum singularity isn't just some relic of the distant past. These singularities might still be out there, existing right now. But where could they be hiding? The answer lies inside one of the most feared monsters we've ever known in the universe, the black hole. The invisible gate to the abyss. So, what exactly is a black hole at its core? It's matter that's collapsed in on itself, trapping its own existence. One day, whether it was a good day or not is up for debate. Far too much matter ended up packed into far too small a space. At the boundary of that volume, the escape velocity, the speed needed to break free from its gravity, shot past the speed of light. And that means not even photons, the very particles of light, can escape its grip. And of course, anything slower than light, which is basically everything else, is even more hopelessly trapped. Black holes just keep growing, constantly feeding on new matter from the universe as it spirals inward. Once something falls inside, no matter what wild events unfold within, it will never escape, not even in the form of light. Everything gets pulled deeper and deeper into the black hole's depths. It's mind-blowing, isn't it? The space around a black hole is a complete frenzy. It's absolute chaos. Particles moving at nearly the speed of light swarm the black hole like moths to a flame, jostling and colliding as they plunge into the dark jaws of this invisible monster. And because they're packed in so tightly, the particles heat up intensely and begin to glow, mostly in the X-ray range. This glowing swirl of energy is what scientists call the accretion disk. More and more matter keeps falling inward, vanishing into the black hole. The gravity intensifies, crushing everything with unimaginable force. Eventually, at the very center of the black hole, the density hits a final extreme threshold. This is known as the Planck density. It's defined by this equation. Here, c stands for the speed of light, h bar is the reduced Planck constant, and g is the gravitational constant. At this density, distances shrink below the Planck length. That's just 1.6 times 10 to the negative 35th meters. And light would cross that distance in only 5.4 times 10 to the negative 44th seconds. That's what we call the Planck time. But what does that actually mean in physical terms? You remember Heisenberg's uncertainty principle, right? The one that says you can't precisely know both the position and the momentum of a particle at the same time? Well, Planck length and Planck time exist right at that scale, where uncertainty becomes so overwhelming, it literally exceeds the size of what you're trying to measure. Space, time, and mass all lose their classical meaning and dissolve into a chaotic mess of quantum gravity. The physical laws we know and trust simply stop working there. And that's why anything could come flying out of a quantum singularity, absolutely anything at all. The heart of darkness. At first glance, those tiny distances and unimaginably short time spans might not seem like much. But how about this? Let me show you something that might just blow your mind. Heisenberg's uncertainty principle can be expressed using this formula. In this equation, delta E stands for the uncertainty in energy, delta T is the uncertainty in time, and h bar is the reduced Planck constant. From this, we understand that the uncertainty in energy, delta E, has to be at least as large as the value you get when you divide h bar by 2 times delta T. If we plug in the Planck time for delta T, the energy uncertainty comes out to an astonishing 1.96 billion joules. That's the explosive energy equivalent to 500 kilograms of TNT. Pretty shocking, right? But here's the kicker. All of that energy is packed into a space the size of a cube measuring just 1 Planck length on each side. That's only 4.1 times 10 to the negative 105th cubic meters. So if you had even one single cubic centimeter of this kind of matter, the energy it would contain is a staggering 4.59 times 10 to the 107th joules. Let's put that in perspective. The Sun, our Sun, radiates a total of about 10 to the 51 joules over the course of 10 billion years. In other words, just 1 cubic centimeter of matter at Planck density would hold enough energy to either create an entirely new universe or obliterate this one in the blink of an eye. That is the terrifying nature of the quantum singularity. And it bears repeating. We have absolutely no idea what's happening inside that region of space, or what might suddenly come bursting out of it. All we can do right now is estimate the kind of energy hidden inside, and those estimates are beyond belief. And all we can really hope for is that whatever's in there never finds a way out. Think of a black hole like an enormous cosmic spiderweb, snaring anything that drifts too close. And at the very center of that web sits a spider, a quantum singularity. That spider devours everything its web captures, and with every bite, it only grows stronger. An unpredictable threat. But what makes the quantum singularity so terrifying isn't just the destructive power it might unleash. It's the fact that its power is fundamentally uncontrollable. We don't even know how to predict its behavior, whether it can be recreated under specific conditions or if it might simply be triggered by chance. And that's exactly where it stands apart from every other threat in the known universe. Comets, supernovae, even gamma-ray bursts, as complex as they are, all follow rules we've come to understand through scientific study. We can anticipate their behavior, build mathematical models, and even develop methods to defend ourselves. But how do you protect yourself from something that doesn't follow any known law? Some scientists believe that in the future, if humanity ever manages to harness quantum gravity, these singularities could one day be used as colossal energy sources, or even as gateways through space and time. Sounds like pure science fiction? Maybe it does. But keep in mind, Today, we can manipulate electrons, photons, and even atoms, things that just 100 years ago would have seemed like sorcery. So, who's to say we won't someday tame the quantum singularity itself? For now, though, the answer remains hidden in the dark mystery at the heart of every black hole. An invisible, silent monster we cannot see or hear. We have no idea how many of these singularities might be lurking out there in the universe. And we have no way of knowing when or where one of them might suddenly emerge. The only thing we can say with absolute certainty is this: if there is such a thing as a truly unknowable point in our universe, then it is the quantum singularity. Of course, scientists are doing everything they can to understand these singularities. Theories like string theory, loop quantum gravity, and the quantum foam model have all been proposed. So don't think of this kind of research as just some abstract brain exercise. It's not some intellectual game or philosophical puzzle. At its core, it's the key to unlocking the origin of the universe, or perhaps it's the ultimate end. If you found this video fascinating, be sure to give it a thumbs up and share it on social media. Thanks so much for watching. We'll see you again next time. Take care.